Imagine you're building an online music player, something like a simplified Spotify or Apple Music. Users can browse, play tracks, manage playlists, maybe even collaborate or share. Now, as you start shaping this app, one of the foundational questions you're going to ask yourself is, who can do what? This is the realm of authorization, defining and enforcing what each user is allowed to do within the system. It sounds simple at first, but the deeper you go, the more nuanced the challenges start to become. Now, in this session, we're going to walk through a Spring Boot-based music player app and see how we can add a robust permission system on top of it using permit.check. But before we jump into the demo and implementation, I want to start by looking at how authorization traditionally works in Spring Boot. What tools are available out of the box, how far they could potentially get you, and where they start to break down. So let's talk about what Spring Boot offers and where it falls short. Now, Spring Security is widely adopted and for good reason. It provides solid primitives like @pre-authorized and @secured and method-level annotations, URL-based access control, role and authority-based access restrictions, and integrations with authentication providers. However, when you're building an app where permissions need to be dynamic, maintainable, and decoupled from the code, for example, when defining who can view or edit a playlist or who can share a track, Spring's built-in approach starts to show some pretty serious limitations. Now, let's talk about some of the things that you can actually run into, or some things that you might be familiar with. And the first one is tightly coupled policy and code. Now, authorization rules are often hard-coded in Java annotations, or inside of the configuration files. Now, changing a policy means touching the code, triggering CI/CD, and deploying the app again. It's a lot of hassle. Now, the second thing, authorization that's application-specific only. Now, Spring's security model lives inside the Spring app. If you have microservices and things like Node.js, Python, or front-end-only apps, you end up creating fragmented permission models, and it just causes extra complexity. The third thing is coarse-grained permissions. Now, most built-in mechanisms are focused on routes and roles. You can check if someone is an admin, but not if they own playlist X or if they can modify track Y. So we're really limited with the kind of policies that we can have here. The fourth point is poor multi-tenancy support. Now, there is no built-in tenant awareness. You have to build tenant scoping yourself and make sure every check respects it. It's really a lot of work. Number 5, no external policy management. There is no UI for non-engineers to view or update permissions. Product, security, or operation teams, they have no visibility and no control. And finally, you get limited audit capabilities. Spring Boot out of the box has minimal logging around permission decisions. There is no history of why access was granted or denied, and there is no audit trail. Now that we know a little bit more about Spring Boot, let me show you the actual app. A simple music player with multiple users you can switch between, and different types of permissions that they have. Now, for the purpose of this demonstration, I kept this project quite simple. It does everything it needs to do, and if you want to do more, it's just a case of expanding it linearly without any more complexity. Now, let's introduce the project. As you can see, we have a basic music player. We have browse songs, where we get a bunch of different songs that render. For each song, we can add it to a playlist or add it to a queue. I have my playlists, and in this case, I'm logged in as Alice. And I have one playlist that I can access and see the songs in that playlist and perform some actions on it. And I also have public playlists. So these are playlists that should be accessible by everyone. Then we have the option to create new playlists and access all the playlists that are public. Now we can also play songs. So for example, if I click a song, it plays, we can shuffle it, we can skip the song to the next one, we can repeat the song and so on and so forth. So all that music player functionality is there. Now, as part of this functionality, I haven't actually implemented an authentication login. So things like auth0, cleric.dev, and so on and so forth, any kind of super tokens, fusion of authentication providers that you might be familiar with, they can very easily be implemented. I basically have just mocked that process to offer even more simplicity here. So I just created a dropdown, and this dropdown allows us to just switch between users. Now, each of these users has a unique ID, and I specifically assigned them a unique ID because a unique ID is what we need to then reference a specific role within permit, and then for that role, be able to have the relevant permissions of what the user is allowed or not allowed to do. Now, as you can see, if I'm Alice, I have a lot of functionality here. Let's say that I can access my own playlist, and this is a private playlist. I can also create a new playlist, and I'll call this a private playlist. And I will deliberately keep this playlist as private, and I'm going to create it. There we go. And then I'm going to go into Browse Songs and possibly add something to that private playlist. So in this case, I'll add this song, and I'll add another song called Song 3. And as you can see, I have permissions to do all of that. But I can also create a public playlist, and I'll call this a public playlist. I'll make this playlist public, so select this. And in this public playlist that we have right here, I'm also going to add some songs. So maybe song 1, I'll add it to my public playlist right here. So Alice has access to all of this, and I can go into this private playlist and see those songs. I can go into this public playlist and see those songs. Maybe I want to delete a song from the private playlist, and I'm allowed to do that, and it has been deleted. But let's actually see what happens if I switch user to Bob. Now, as soon as I switch user to Bob, you'll notice that we lose access and visibility of all the private playlists of Alice because they're private. So it means that we shouldn't be able to access them. But also, if we go into a public playlist, you'll notice that we can go ahead and play that song. However, if I, for example, try and delete the song, I won't have the permissions to do so because I haven't been the person that has originally created that playlist. So the user ID of the person that created the playlist has the unrestricted access to perform all tasks, whereas the person that has the restricted role, in this case, someone that can view the public playlist but not perform actions on it, well, therefore, it is much more restricted. But in the same way, I can browse the songs, I can view my playlists, I can create public playlists or private playlists for Bob. And if I create this playlist, and let's say I can do that and I want to add a song to that playlist, let's say song 4, as you'll see, it only renders either public playlists or the private playlist for that specific user that is currently logged in. So as you can see, we have this authorization logic that's working in the background. And we also have this logic configured within permit. Rather than giving you a quick overview of what that logic looks like in permit, I'm going to actually run you through creating that whole logic and then show you how it works. All right, so let's transfer ourselves into the policy editor and let's actually create our first policy for this music player. Now, I'm going to think out loud here and I'll show you how I'm thinking about designing this policy. Now, what you can see is the permit app where we have all the options to create and configure policies. That means create the roles, the resources, the actions for those resources, add the users, and so on and so forth. Now, the first thing we're going to do is we're going to direct into our policy editor. This is the place where we can create our resources and add our roles. And the first thing we need to do is actually create the resources that we're going to be working with. These are the things that we're going to be interacting with and performing actions on. So in this case, if I go to resources and I'll create our first resource, the first thing we're interacting with is the playlist. The playlist is what a user should have some restrictions on being able to, in this case, see, right? The distinction between the private and the public playlists. So we're going to call this a playlist. And the actions that we're going to add, I'm going to change them. We'll have two actions on the playlist. We'll have an action called view public, which means we can view a public playlist, and view private, which means we can view a private playlist. And we can save this change. Now that's our first resource created, and we can expand it to see the actions we have defined on top of that resource. So now let's add another one. The other one is going to be a song. The song is going to be the second resource that we're going to perform actions on, and those actions will be add to playlist. So we can add the song to a playlist of our choice. Add to queue. We should be able to delete the playlist, delete the song from a playlist, and we should be able to play a song from a playlist, right? So those are the actions that we defined here. Obviously, we could have more actions on, for example, a playlist. We might be able to delete a playlist or add a playlist or create a playlist. But I'm just keeping it fairly simple for the time being. So as you can see, we have a song resource with all the actions that we'll be needing for this project and a playlist resource with all the actions for the project. So now that we have a song and a playlist resource, the next thing that we want to do is actually create roles. Now, by default, Permit creates 3 basic roles: an admin, a viewer, and an editor. Now, 2 of these roles will actually, or actually 1 of these roles will want, but I'm just going to delete all of them for the time being. And we're going to go through the process of creating our own roles. So I'm going to delete the editor role, and then I'm also going to delete the viewer role. So now we're going to create our own roles. So I'm going to just create a role here. And the first role we're going to create is the owner of a playlist, the owner of the songs in that playlist. So I'm going to type in owner and save this. And that's how simple it is to create roles. And the other role is going to be viewer role. So we'll be able to view those playlists. Okay. So we defined the roles, we defined the resources. So now if we go back into our policy editor, you'll be able to see that for each role, we have the resources and the corresponding actions. Now, Permit has this type of view, but it also has a grid view where, it's just a matter of preference, how your brain works and what you prefer. I've always been a fan of the basic tile view because it really gives you a nice separation over each role and what it does. And now it's the time to define those permissions. So what can an owner role do? Well, an owner role has access to all the private playlists that I have created, but can also view all the public playlists. And also in regards to song, I can do everything. I can add to playlist, add to queue, delete, play. At the end of the day, I am the owner of the playlist, therefore I am the owner of the songs, and I'm able to do everything. However, a viewer should not have access to any private playlists, so they can only view public playlists, and they should only be able to add to queue, because that's just a thing that anyone who has access to a public playlist can do. They cannot add to the public playlist. They can't delete songs from the public playlist because that playlist, even though it's public, it has been created by a specific user and it belongs to that user. But they can play the songs in that playlist, of course, and we can save those changes. And now what happened is that policy is now in place. So when we actually enforce this in the code, the PDP, the policy decision point, which we will soon launch and show you how that works, the policy engine will be able to access all these policies and in real time confirm whether a specific user can perform specific actions on a specific resource based on the role they have. But now you're probably questioning, okay, I have a user that's logged in. How do I assign a specific role to a user? Well, within Permit, whenever you're working with an authentication solution, you need to sync those users into Permit. So the unique identities that the authentication solution gives you, you need to sync and provide them inside of Permit, so Permit knows about that specific user and therefore knows about the role. Now, in our current project, what we have done is we created just a very basic drop-down so we can switch between 2 users. We kind of skipped the part of creating the authentication solution just to really simplify this Java project. But the concept is still there. Each one of these users has a specific unique ID that we're going to be referencing and then assigning a role to. So now when I go back to the policy editor, I can go into the directory, and here is where I can add my users. So I'm going to add my user. The first one, I'm going to give a unique key. It's going to be user underscore 0001. This is the unique key I have assigned to the user, and we're just going to go by first name and call this user Alice. And here is where I can assign the role to that specific user. And I want to make Alice the owner. So she has permissions to everything. And now we need to add the second role. The second user in this case is user 0002. And we're going to call this user, he was called Bob. And Bob in this case is going to be the viewer. and we can save those changes. So where are we now? Well, we've got users that have a specific role of an owner or a viewer. We've got our policy configured of what an owner or what a viewer can do. So now all we have to do is add permit to the application, which means creating an instance of permit, launching the PDP, and creating the enforcement points to restrict the permissions. So let's go ahead and do that now. All right, so the first thing we want to do in order to be able to work with permit is to understand where you can fetch your API key from. The API key is going to be important for two reasons. First of all, we're going to have to initialize our object with the API key. And secondly, the PDP, the policy decision point, or the microservice for authorization that contains that policy engine, also needs to know of the API key, so it knows exactly what type of policy to reference. Now, we can get our API key by just going to our permit application, clicking on our profile picture, and copying the environment API key. Now, that API key, because we're working with a Java project, and in this case, for this specific project, we are actually using Maven. Inside of application properties, we define what is part of our initialization object, which is the domain name at which the PDP is going to run, and we paste in our permit API key. Now, by the time you're watching this video, this API key will have been rotated, so there is no point trying. Let me actually just give you a really quick overview of why I decided. Let me just give you a really quick overview of what we're using here. Now, as part of working with Spring Boot and working with a Java project, there's two options when we work with permit of how we install the dependency. And that depends on the build system that we're using, whether it's Gradle or Maven. Now, in this case, we are using Maven. Now, you might be unfamiliar between the differences of Maven and Gradle, so I'll give you a very quick overview. You use Maven when you need a reliable, convention-based build system that is easy to understand and well-suited for pretty much a very straightforward Java project with minimal customization, something very similar to just a very simple music player. However, you need to use Gradle, or you should use Gradle, when you need faster builds, more advanced automation, or have the flexibility to fully customize complex workflows in a very large project. Now, in the permit documentation, if you actually look at the quick start for Java, you will have the option of picking between a Maven and a Gradle implementation. Now, we went ahead with Maven because that, of course, like I just explained, is suited for our project. Now, if I actually go back to Visual Studio Code, that dependency that we're putting in is suited for Maven, and that is the dependency we put into our pom.xml file. So if I scroll somewhere here, you will start to see, here we go, that we have a dependency, and this is the permit dependency to work with the Java SDK. Now, once we defined our dependency, added our configuration keys, the next thing we need to do is create a permit SDK config class. Now, if I go to under main Java config, I can go on the permit SDK config. Now, I created the permit SDK config as a separate class because it will allow us to use permit in different parts of the application seamlessly. So we can just inject the functionality and perform our authorization checks. Now, in our case, in this specific permit SDK config class, we define the method that returns here, as you can see, a permit instance, and we annotated this instance with a bean. And by doing so, what we're telling the Spring application is that, hey, manage this Spring instance as a bean, create it once, keep it around, and inject it whenever it's needed in the app. It's just a much cleaner way to work with permit when using Spring Boot. All right, so we initialized the object, we created a nice bean to handle permit throughout the application, we added our application properties, we configured our dependencies, and now really we just need to create the enforcements and run the PDP. Now, how do we run the PDP? Well, the PDP is an external container that we need to run. You can essentially pull the container from the container hub and then just run it inside your terminal with the API key. Let me show you. I'll open up my terminal, and this is the command you need to run. You run docker run with the specific port that we have already defined in our application properties. We turn on the debug flag to true so we can see all the consoles of what's happening. And we pass in our PDP API key. That is the API key that we have copied from the permit application. And then we run the name of the container. Now, as soon as I run that, you'll see that the container launches, that policy engine starts to run. It connects to the specific policy that we have configured inside of permit. It's waiting until a specific logged user hits that permit check. So then that permit check can send a request to the PDP to find out whether the user can perform a specific action on the resource based on the policy that we have configured. So really now what we have left remaining is just to create the permit checks in the application to create all of those enforcements. Now, because when using Spring, we have the Spring MVC architecture, the model view controller. As part of the controller part, this is where all our permit checks go. This is the backend functionality of the Spring Boot application, which allows us to handle incoming HTTP requests, process them, and return an object that is relevant for our needs. Now, as part of the controller, you'll notice that we have a playlist controller and a song controller. Now, the playlist controller is the logic to handle everything to do with a playlist, and the song controller is the logic to handle everything to do with an individual song. Now, this is where our permit checks live. Now, if I just search for a permit check, just so we can find it a little bit easier, you'll notice that initially we have some functions. This function is called getPlaylistById. And as part of this, we have a permit check. Now, this check, when it gets the playlist, it checks whether the user can view the public and view the private playlists. So as it runs through the playlists, it performs the check, and therefore it returns the result whether that user can see the private playlist or not, depending if they have the owner role or not. Now, the second check that we have here is the check to see if the user has permissions to add a specific song to the playlist. Now, if we see this permit check, we're passing the specific unique user identity as part of the three parameters that are required. We're passing in the action we're performing and the resource we're performing that action on. And finally, we have another check, and this check confirms whether the user has permission to delete songs from a playlist. So as soon as the user gets to this point, this request gets sent to the PDP, the policy decision point, the policy engine inside it, gets the details of the particular user ID that is asking if he can delete a specific song. Then that PDP looks at the policy, checks the role for that particular ID, and then checks if the user can therefore delete a song, and if they can't, they get rejected, and if they can, it gets approved and it passes. And then that try statement, we move on to the next part. Otherwise, it moves into the catch, and we say that the permit check has failed. The same thing happens in the song controller. We import the permit SDK, we enforce the resource, and then if I just scroll down to permit check, here we can see where we're checking if we can play a song, and here we're checking if we can add the song to a queue. And in regards to the permit functionality, that is essentially everything. This allows us to, when we enter back into the project, to be able to, for example, see Alice's jams and create a new playlist, or maybe even delete a specific song from a playlist. And as I do that, you can see that we have, in this case, been approved to delete a song from a specific playlist. And the beauty of permit is that on top of the policy, because we're running with a policy decision point, all of those permissions are being logged. So as you can see, in this case, I was trying to delete a song as a user, and that permission was permitted. Then I wanted to view a private playlist, and I was also permitted. And the beauty here is that we can click on a specific audit log if we're unsure of what happened, and we get a reason for why this policy passed. So in the same way, if we, for example, are denied, and in this case, we can see that we had a deny here where I tried to play a song as user one, and in this case, I have temporarily removed my permissions for being able to play a song as an owner. And as you can see, we can then look at that reason. A user with this particular ID does not match any rule that grants him the play permission to the given resource of type song. So really, with the basics that I have introduced to you of working with the Java SDK and permit and running a Spring Boot app, you can really, really easily work on adding more complex and more granular permissions into your Java applications and having it all separated from that model view controller, apart from running those specific enforcements inside the application. So really scaling it right now is very, very simple. You can simply move into ABAC, so attribute-based access control, and REBAC, relationship-based access control, to really enhance the granularity of what you would like to manage and authorize inside of your project. Authorization is too important to be hard-coded and too dynamic to live only inside your app. With permit.io, we've seen how you can bring powerful, flexible permissions into your Spring Boot application without losing control or adding any sort of friction. If you're building anything with users, roles, or any type of access control, please don't reinvent the wheel. Check out the demo of the project I have linked in the description. That will lead you to a GitHub project that you can clone and play around with yourself. And also make sure to click the link for permit below to explore it for yourself. Thanks for watching.